Hello everyone, welcome to today's session on Milne's method, a design thinking approach from numerical solution of ordinary differential equations. So I am Mr. P.M. Chellapandi from the Department of Mathematics. I have been working as an assistant professor in SNS College of Technology, Coimbatore. So in today's session, we are going to learn what is Milne's method using design thinking approach, which is a numerical technique used for solving ordinary differential equations. So unlike basic numerical methods, Milne's method follows a predictor-corrector approach. This means we first estimate a value, then we improve that estimate for better accuracy. So today we will understand this concept through the design thinking process and see how it helps solve real world problems. Let us begin. So here the first part in design thinking is empathize. So we need to empathize our problem. So here, why do we need Milne's method? That is my question. So let us begin with this first stage of design thinking called empathize. So we need to understand the real world problem before finding solutions. Consider whether forecasting. Meteorologists need a predict tomorrow's temperature using today's available information. Similarly, think about rocket trajectories. So, scientists must predict future positions of rocket based on present velocity and acceleration. In such situation, calculations become very large and complex. So traditional methods may become slow when handling large scale computation. So therefore, engineers and scientists need efficient numerical methods to that provide accurate results quickly. So this creates the need for Milne's method. The second part in design thinking is define. So here the core problem is represented by an ordinary differential equation. So we are given a relationship of the form dy by dx equal f of x comma y, right? Our objective is to estimate future values of y efficiently. So however, there are several challenges. The first challenge is large calculation, right? So the second challenge is time consumption. The third challenge is maintaining accuracy. So the core problem is how can we calculate future values accurately without performing excessive computations. So that is my questions, right? So let us go to next slide. In the next slide, we are going to discuss what is the ideate part. At this stage, we think about the possible solutions. The first method is Euler method. Euler's method is simple and easy to apply. However, its accuracy is limited. The second method is Runge-Kutta method. Runge-Kutta provides high accuracy, but it requires more calculations. Now, imagine another approach. Can we first predict value and then improve it? So this becomes the key idea behind Milne's method. So instead of directly solving the problem, we first estimate and then we refine the estimate values, right? So let us go to next part. Here we are going to introduce what is Milne's method. Now let us formally understand Milne's method. Milne's method is a predictor-corrector numerical technique used to solve ordinary differential equations, right? So it works in two stages. The first stage is predict. In this stage we estimate the next value. The second stage is correct. In this stage we improve predicted values, right? So the overall process can be summarized as predict, verify, improve. This approach gives better accuracy compared to simpler methods, right? So the next topic is predictor. Let us understand what is the predictor formula. The predictor formula estimates the next value using previously known information. So this formula uses 4 previous values. The important point here is that it does not require the new function value directly. That is why it is called an open formula. The predictor gives us a quick estimate of the next value, right? So let us go to the next slide. Here we have corrector formula. Let us come to prototype. So the corrected formula is our prototype. So suppose we are given dy by dx is equal to x plus y, and we already know values at x equal to 0, then it gives 0 0.2, 0 0.4 and 0 0.6. We need to find the value at x equal to 0 0.8. So first we have to calculate the function values, then we have to apply the predictor formula and obtain the estimated value. Then we use the corrector formula to refine that value. Finally, we obtain the corrected results. So this step-by-step process demonstrate how Milne's method works in practical situations, right? So let us test and evaluate this situation. So the advantages include it is faster than Runge-Kutta for multi-step calculations. It provides better accuracy than Euler's method. So its efficiency reuses previous values. So now let us discuss limitations. So Milne's method requires 4 initial values before starting. Poor predictions can sometimes propagate errors. So also the method may become unstable for certain complex equations. So every numerical method has both strengths and limitations, right? So Milne's method combines prediction and correction to provide efficient numerical solutions. The design thinking process helps us understand why the method is needed and how it solves practical problems. So the idea can be summarized as understand the problem, predict the solution, correct the estimate, validate the results. This reflects the design thinking mindset of predict, correct, improve. So thank you everyone for listening. I hope this session helped you understand Milne's method clearly by using design thinking approach. I will meet you with a different concept in the next video. Thank you.